This is 7th grade lesson 5.4. The objective: students will use scale drawing to find a missing measure. The standard covered are 7G1. The page numbers out of the hardcover book are pages 212 through 217B, and out of the practice journal, pages 119 through 122B. Okay, today we're going to be working with scale drawings, and we'll actually probably come back to this later in the chapter. A scale drawing is a proportional two-dimensional drawing of an object. So this would be like on paper. A scale model, on the other hand, is going to be three-dimensional. So like a toy car would be an example of a scale model. So it's a proportional three-dimensional figure of an object. The scale gives the ratio that compares the measurement of the drawing or the model to the actual measurements. So the key thing to remember is the first number in that ratio. If it's set up as a fraction, the top number is going to be like your model or scale drawing number, and your second number or your bottom number is going to be the actual number, okay? And that's very important to understand that. So here it says, what is the actual distance D between Cadillac and Detroit? So we're looking at a map. So a map is one place that's actually considered a model. A map is a shrunk down model of an actual distance. Okay, so here when we look at this, we've got our map, and I went ahead and did some marking so that we could see that it was actually, of these distances here, it was actually 1, 2, 3 and a half of those distances that were stated there. So the scale that they gave us was 1 to 50. So for every 1 centimeter, which for you guys is, I think it says centimeter in your book, but for me, because I'm up on a really large board, that's bigger than a centimeter, is the same as 50 miles. Okay, so that is my scale. So 1 centimeter was 50 miles. I measured out that it was 3.5 centimeters if we were able to take that without just like flying and not having to go across roads. So now we get to work like we did previously. We're going to cross multiply and then divide. So we're going to take 3.5 times 50. And then that divided by 1 is still the same. So 3.5 times 50 gives me 175 miles. So it's actually 175 miles between those two locations. Okay, so we're going to go ahead and practice using a scale and finding a distance. Oops. Okay, so here's another situation. It says if the scale of a map is 1 centimeter to 50 miles, so 1 to 50 if you like to see it as a fraction, which I prefer. What is the actual distance between the two cities that are 7 centimeters apart? So 7 centimeters, where's our centimeters? Well, that's our scale drawing, or we can match labels, that's the top. We're gonna cross multiply, divide, so 7 times 50 gives me 350, divided by 1 is still 350 miles. So two cities on a map are 7 centimeters apart. That means they're 350 miles apart in actual life. Okay. If the scale of a map is, once again, 1 centimeter to 50 miles, so 1 centimeter to 50 miles, what is the distance on a map between two cities that are actually 425 miles apart? So this would be where, if you're creating a scale figure, like you're creating the map, you're going to have to understand how far apart am I going to have those figures on the map? Well, my 425 miles is going to go on the bottom, because that's the actual distance. That's my mile labels. So now I'm going to cross multiply, divide. So 425 times 1 is 425, divided by 50 gives me 8.5. So I'm going to have to make sure if I'm drawing this on a map that I make them 8.5 centimeters apart. Okay. All right, I want you guys to try this one. It says if the scale of a map is 1 centimeter to 50 miles, what is the actual distance between two cities that are 3 centimeters apart on a map? You should have gotten 150 miles. So that's working with scale, both either deciding the actual distance, or we also practiced one in the reversal where if we were making the map, how far we would have to do those two cities apart. So that's working with a scale, okay? So here's another situation of working with a scale. So it says, the liquid outer core of the Earth is 2,300 kilometers thick. A scale model of the layers of the Earth has a scale of 1 inch is the same as 500 kilometers, or to 500 kilometers. How thick is the liquid outer core of the model? Okay, so let's set up our scale first of all. So our scale was for every 1 inch that we do in the model, that's the same as 500 kilometers in real life. So the third piece of information is the liquid outer core of the Earth is 2,300 kilometers thick. Matching labels, or hey, this is the actual distance. Actual distance is on the bottom, 2,300 kilometers. Okay, cross multiply, divide. So 2,300 divided by, or times 1, same thing, divided by 500, gives me 4.6 inches. So if I'm making this model, I need to have that liquid outer core be 4.6 inches thick. Okay, so I want you guys to try this next one. Okay, so now you're still making the same model, but this time you're doing a different layer. Okay, so the mantle of the Earth is 2,900 kilometers thick. How thick is the mantle of the model? So I need to pull this back out to get our original scale model. So our original scale was right here. 1 inch is the same as 500 kilometers in real life. Okay, so you're going to go ahead and set up your ratio using your third bit of information. And then find out how thick that needs to be on the model. Oops. So on your model, it needed to be 5.8 inches thick. Okay, so that's working with the model. So the first time we did a map, here we did a model where if we were creating the model, how thick would we need to make that? Okay, so here we're going to continue working this, but we're also going to talk about scale factor. So it says a scale can be written without units, so those labels of inches or miles or centimeters. So it can be written without units when the units are in the same format. So for example, this cannot be written as a scale factor. This is a scale. Notice we had inches and miles, but in order for us to write it out as a scale factor, they would have to have the same units. So I would either have to change my miles into inches, which would be a huge number, or my inches into miles, which would be like a really, really small number. So it's not very practical in that scenario, but sometimes it is. When you're working with two units that are kind of close to each other, you can convert and change them into scale factors. So it says a scale factor is one that does not require units. So here we have a situation. It says a scale drawing of a spider is 5 centimeters long. The actual spider is 10 millimeters long. What is the scale of the drawing? So we're going to do something like this to begin with our actual units. So we want to do, it's our scale over our actual. Okay, so I need to break this apart. So it says a scale drawing, scale, is 5 centimeters. So 5 centimeters over my actual, the actual spider was 10 millimeters. 10 millimeters. Okay, so now we want to reduce this down to lowest terms. So we're still going to keep the same labels, but we're going to reduce the numbers down to lowest terms. So 5 would go into both of those numbers. So now that becomes 1 centimeter is the same as 5 millimeters actually. Okay. Now to convert that to a scale factor, we have to convert those so that they have common units. So we can decide to either change them to centimeters or into millimeters. It really doesn't matter. I'm going to go ahead and convert them into, I'll do both. Okay, so if I want to convert, remember our King Henry dies or doesn't usually, so base or units, so we're doing meters, drink chocolate milk, okay? So King Henry doesn't usually drink chocolate milk, or I use King Henry dies by for base, drinking chocolate milk. So I'm going from centimeters to millimeters, one spot to the right. So I already have this one in millimeters, so this one goes one spot. So this is the same as 10 centimeter, or not 10 centimeters, 10 millimeters over 5 millimeters. Or I could do the opposite, which would be, I could convert it to centimeters, so I'd go the opposite way with my millimeters. So opposite would be here, 0.5. My other one would be 1 centimeter to 0.5 centimeters. Okay, I'm going to go ahead and use this one. And it really doesn't matter. A scale factor is not going to matter. So now if I go through and I change this, it becomes reduced down. This would be 2 to 1. Or 2 over 1. Okay, so that's working a scale factor. Scale factors is just one extra step of doing that converting. It's used sometimes. They will do this if you have ever looked at like the bottom of a toy car. They have the scale factor on the bottom. It'll say like 1 to 800 or whatever the number is, 1 to 80. They do this on actual things. So if you ever look at a toy car, look at the bottom of it and you'll see a number that looks like that. So here we have a model has a scale of 1 millimeter to 20 centimeters. What is the scale factor of the model? Okay, so once again, we go millimeters to centimeters or centimeters to millimeters. It's not going to matter. So let's convert our centimeters to millimeters. So centimeters, millimeters. And my King Henry doesn't usually drink chocolate milk. I'm going to go one spot to the right. So centimeters, right now my decimal's there. I'm going to go 1 to the right. So it becomes 1 millimeter over 200 millimeters. So my scale factor would be 1 to 200 or 1:200. Okay, and this is just converting it into centimeters. If I converted it to millimeters, that would be fine, but usually you don't have a decimal number in a scale factor. Doesn't mean you can't, but usually they will go with the larger unit. Okay, so let's try one more of these. A scale factor is 1 centimeter to 20 meters. Or sorry, a scale is. Find the scale factor. Okay, so King Henry doesn't usually meters drink chocolate milk. Okay, so I am going to go to meters. So centimeters, let's convert my meters to centimeters. So meters to centimeters would be 1, 2 places to the right. So my decimal right now there. So 2 places is going to be 2,000 centimeters. So now I have these in the same unit. So my scale factor would be 1 over 2,000. Or you could write it out like this, 1 to 2,000. I know usually this is the way I've seen it whenever they've done a scale factor, as I've seen it with the colon versus in the fraction format. Okay, so I'm going to give you guys one to try. Once again, we'll work metric system. So let's do 1 centimeter to 5 millimeters. Okay, so here I would convert into millimeters. Okay, so convert into millimeters. Okay, so go ahead, convert your centimeters into millimeters, and then reduce if you have to. you should have gotten a ratio or a scale factor of 2 to 1. Okay, this is probably the most difficult part, is working with that scale factor. I'm just trying to introduce that to you. I probably will not be assessing you on scale factor. It's just something I wanted to introduce to you and have you practice a little bit. Okay, so the key thing to remember out of this lesson is when you set up your working with a scale, you want to make sure that you understand that in the scale, the first number stated is the model or the map or whatever, and the second number stated is the actual distance. Make sure that you're matching when you set up your proportions.